Hello everyone, welcome to EEEE lecture number 10 and we are going to solve today one numerical on maximum power transfer theorem. So here is the numerical. So here we have to find RL and determine the maximum power delivered to the load. So let's begin. So this is my circuit. So first of all, I have to find the unknown value of RL. So let us mark these points as A, this terminal A and B. All right. And for maximum power transfer theorem, we need to find RTH, then VTH, and then we can say that RTH is equal to RL, and then we can find the value of RL. All right. So the flow will be, let me explain the flow. So the flow will be, first we need to find RTH, then we need to find, then we say that RTH is equal to RL. I mean, RL is equal to RTH. We got the value of RL. Then next we need to calculate VTH, and next part we'll calculate the maximum power, which will be VTH square upon 4 RTH. So that is our strategy. All right. So let us first start with finding the value of RTH. So how do we find RTH? We deactivate all sources. So which all sources we have? We have 25 ampere current source, 10 ampere current source, and 30-volt voltage source. So all the current sources will be replaced by open circuit, and the voltage source will be replaced by short circuit. And we have to remove load RL. So let's do that. So first of all, we'll find RTH. So for finding RTH, what are the two steps? Remove load RL, and next step is deactivate all independent sources. So all sources are independent over here. We'll deactivate it. What is the meaning of it? Current source, we will replace it by a open circuit, and voltage source will replace it by a short circuit. All right. So let me show you the diagram and then do the connections over here. All right. So let me take black color. So here we have a current source. So it will be open circuit over here. Then we have a resistance of 5 ohms. Then another resistor of 10 ohms. This will be again open circuit. Then we have to remove the load terminal. So this will be terminal number A, terminal A and B. Then we have another resistance of value 2 ohms over here. Then another resistance of 10 ohms. This is 2 ohms. And here will be a voltage source will be replaced with a short circuit. All right. So this is a circuit over here. Let me highlight this part. And we have to find the resistance RAB. Okay. Resistance between the terminals A and B, RAB or RTH. All right. So if you see this 10 ohms is in parallel with a short. So this 10 ohms resistance is in parallel with a short. So this 10 ohm resistance will become redundant and will be replaced with a short circuit. All right. So let me redraw the circuit over here. So this circuit will get reduced to the following. So over here we have 5 ohm resistance. Then we have 10 ohm resistance. Then we have terminals A and B. And on that side we have 2 ohm resistance will be there. And this 10 ohm resistance will be replaced with the short circuit. So here we'll have 2 ohm resistance. Alright. Now if you see carefully, this 5 ohm resistance and this 10 ohm resistance will be in series. So you can write over here, this will be 5 ohm plus 10 ohm, that will be 15 ohm. So the following circuit will reduce to the following. So we have 15 ohm resistance and we have 2 ohm resistance, and here we have terminals A and terminal B. So if you see carefully, your RAB or your RTH will be 15 ohm parallel to 2 ohm. So that will be 15 into 2 divided by 15 plus 2. So that will come out to be 1.765 ohms. Alright. So that is my equivalent resistance or Thevenin's resistance. Alright. Now we can write a statement that for maximum power for maximum power to be transferred from source to the load. For that, we have to keep RL should be equal to RTH, and that is equal to 1.765 ohms. All right. So we got the unknown value of load resistance, and the value is 1.765. All right. So next thing is we need to find the value of VTH. And for finding the value of VTH, following is the procedure. So let me write over here. Point number second point. We need to find Thevenin's voltage. So find VTH. What's the procedure in it? First step is to remove the load resistance RL, and second step is calculate the open circuit voltage VUC or VAP or VTH. All right. So let me go back to the circuit. So in this circuit, we have to just remove load RL and calculate the open circuit voltage between the points A and B. Okay. So let's do that. Let me redraw the circuit for you all. So here we have 25 amperes current source. Then we have a resistor of 5 ohm resistance. Then here we have 10 ohm resistance. We have a current source of 10 amperes. Then we have another 2 ohm resistance over here. This is 10 ohms, 2 ohms, and you have a voltage source over here. All right. And okay, and these are points A and B. This is A and this is B. Okay. So basically what we need to do is we need to find the value of, okay, let me write this value. This value is around 30 volt. So we need to calculate VAB or VTH. All right. So how do we do that? Always start with B and you can go from this side. Okay. Above and go back to the terminal A. So you started with B. Okay. So what will be VAB now? This is minus plus. Okay. So let me add over here the points. Let me write with red color. This will be minus, this will be plus. So what will be VAB? So we are going in this direction from B to A. So here there is a rising potential, so that will be 30. Let's say that current in this loop is 2I2. So it is going, opposite to the direction of to the flow. So I2 and this flow is opposite. So it will be plus I2 into 2. So your VAB will be 30 plus I2 into 2 ohms. All right. So we need to find the value of I2. So before doing that, first of all, one more observation is there that this current source will be in parallel with this 5 ohm resistance. All right. So we can convert this current source in parallel with this parallel resistance to a voltage source in series with resistance. All right. So let me draw the circuit again. This will be reduced to the following. So a current source in parallel with a resistance will be converted into a voltage source. So that voltage source value will be V is equal to I into R. That will be 25 amperes into 5. That will be 125 volt. And it will be replaced with the series resistance of 5 ohms. Let me add over here. This is 5 ohms. Then we have another 10 ohm resistance. Then we have a current source of 10 amperes. Then remaining part of the circuit is remaining the same. This will be 30 volt. Okay, then do the connections over here. All right, this will be 10 ohms, 2 ohms, 10 ohms, and 30 volt. All right. Now we know that we have defined the current direction as follows over here. This will be I2. So there will be 3 loops. This is I1 and this is I3. All right. Now we can easily apply mesh analysis and do the further part and calculate the value of I2. Because once we know the value of I2, we can use this VAB formula 30 plus I2 into 2 ohms to calculate the value of VAB. So if you see carefully, it's an example of a super mesh. So over here we have a 10 ampere current source common between mesh 1 and mesh 2. So this is my super loop which we need to apply the KVL. Alright. So this current source is set between I1 and I2. Okay. So how we can write it as? We can write it as I2 minus I1 is equal to 10 amperes. So this we call it equation number 1. Okay. So why it is I2 minus I1? Because I2 direction and 10 ampere current source direction are same. Okay. And also next step we can write it as mesh number 1 and 2 form a super mesh. Okay, so there are three unknowns I1, I2 and I3. Will require three equations. So what will happen when we apply KVL to this super mesh over here, this yellow color loop which we have applied? So here we are writing minus plus, so it will be 125 minus, here we have 5 I1 minus 10 I1, then we have to go over here, it will be minus 2 I2, and then here it will be minus 10 I2 minus I3 is equal to 0. Alright, we rearrange the terms. What do we get? Minus 15 I1 minus 12 I2 plus 10 I3 is equal to not 0, it is equal to minus 125. So this becomes our equation number 2. Then we can apply a normal KVL to loop number 3 or mesh number 3. So we can write over here KVL to loop 3. So this is my loop 3 over here. Let me mark it the blue color one. This is loop number 3. So we need to apply the KVL over here. So it will be minus 10 I3 minus I2. Then we are going from positive to negative. So here it will be minus 30 is equal to 0. So what do we get? 10 I2 minus 10 I3 is equal to 30. This becomes equation number 3. Now we have three equations and three unknowns. So let's put it in a matrix form. So we are putting it in matrix form. So it will be I1 over here, I2, I3. That will be equal to, this will be coefficient of I1, that will be minus 1. Coefficient of I2 according to equation number 1, 1. And I3 coefficient is 0. And on the right hand side we have 10 amperes. Okay. Second equation is we have coefficient of I1 as minus 15, minus 12 coefficient of I2 and 10 over here. On the right hand side minus 125. Here we have coefficient of I1 as 0, I2 as 10 and I3 as minus 10, and here we have 30. So kindly solve this simultaneously using a calculators and let me know the value of I1, I2 and I3. So I1 is coming out to be 75 by 17 amperes. I2 is coming out to be 245 by 17 amperes, and I3 we got it as 194 upon 17 amperes. Alright, but what a value of we are interested in? We are interested in specially I2, and what will be VAB? 30 plus I2 into 2 ohms. So we can write over here, we can calculate it here itself. VAB will be 30 plus I2. How much did we get? 245 upon 17. So 245 upon 17 into 2 ohms. So how much is this? This is coming out to be 58.82 volts. All right. So once we know the value of, and that is equal to VTH. This is equal to VTH. So once we know the value of RTH and VTH, we can calculate maximum power. So we can write over here, P max will be VTH square upon 4 RTH. So how much is VTH? 58.82 square divided by 4 times RTH is 1.765. So this will come out to be 490.05 watts. So this is my maximum power through the load resistance RL, and RL value is 1.765. All right. So this is how we can solve a numerical on maximum power transfer theorem. Again I repeat, we were supposed to find RL and determine the maximum power delivered to the load. So we have first find RTH, and then we told that for maximum power to be transferred to From the source to the load, RL is equal to RTH. So we got 1.765 ohms. The next step we require to calculate VTH. So we found out that we converted this by source transformation, right? And then we have applied the mesh analysis and found out the value of I2, and which gave us the value of VTH. Then we calculated the maximum power, that is by the formula VTH square upon 4 RTH, and we got the value as 490.05 watts. Okay. So we have completed two numericals in the last lecture and one numerical today for maximum power transfer theorem. Now we go to superposition theorem, the last theorem which we have to discuss. So basically it is used to solve the network where two or more sources are present or connected. So it is only valid if there are minimum of two sources, either a current source or a voltage source. Alright. It can be a number of sources, but it should be more than two sources. Alright. So what is the statement of it? In a linear network containing more than one independent source, okay, more than one independent source, the resultant current in any part of the linear network is equal to the algebraic sum of the currents produced by each source separately. Now, to understand this statement, what we will do is, we will take an example. So let us continue. Again, I repeat, the statement of superposition theorem says that in a linear network or a circuit containing more than one independent source, the resultant current in any part of the linear circuit is equal to the algebraic sum of the currents produced by each source separately. So to consider an independent source alone, we replace the voltage source with a short circuit and current source with open circuit. So let me explain you with an example. All right, so then you will understand it thoroughly. So let's take the example of numerical number 1. All right. So we need to find the current through the 2 ohm resistance using superposition theorem. So how many sources we have over here? We have sources, 40 volt voltage source, 20 volt voltage source and 10 volt voltage source. All right. So what do? Is we first consider 40 volt voltage source alone. So when we consider 40 volt voltage source, other voltage sources are replaced with a short circuit. All right. And due to 40 volt voltage source, let's say the current flowing through 2 ohm is called as I2 dash. Okay. I2 dash, simply I2 dash. All right. Next we consider 20 volt voltage source. Then 40 volt and 10 volt will be short circuited. So now we call whatever current we get to I2 is called as I2 dash. And next case we consider 10 volt voltage source, and whatever the value of I2 we call it as I2 triple dash, just to separate, the separate notations are used for every independent source. And then what does the superposition theorem says? That the algebraic sum, here it is, the algebraic sum of the currents produced by each source is equal to, the total current which is flowing through 2 ohm resistance. So I of 2 ohm will be, according to superposition theorem, I2 dash plus I2 double dash plus I2 triple dash. So this is in short, what do you mean by superposition theorem? So this is your superposition theorem. All right. So this is just the flow. So let's start solving the numerical on superposition theorem. We need to find the current. So first step is consider 40 volt voltage source alone. So when we consider 40 volt voltage source alone, 20 volt and 10 volt will be short circuited. So let's do that. So I'm drawing the circuit over here again. This is 40 volt. This will be 5 ohm. This will be short circuited. Then we have 10 ohm resistance. Then here we have 2 ohm. And here this is short circuited. All right. And we are supposed to find the current through 2 ohms. So that will be I2 dash. All right. Now, the next immediate thing which comes to our mind is make 2 ohm parallel to 10 ohm. We cannot do that because we cannot do any manipulation with 2 ohm resistance. It cannot be taken as a resistor in series or parallel because we need to find the current through it. So we cannot disturb it. So what we can do is we can simply apply mesh analysis. All right. So what do we do when we apply mesh analysis? We consider two loops. So this loop, consider it as I1, this as I2, and remember I2 is nothing but your I2 dash in the loop. Okay, so we'll apply KVL to loop number 1. So what do we get? Plus 40 minus 5I1 minus 10 I1 minus I2. We'll quickly write the equations. So here you will get that is minus 15 I1 plus 10 I2 is equal to minus 40. Let's call this equation number 1. Alright. So simple mesh analysis we can apply. Now next case may we'll apply KVL to loop number 2. So what do we get? Minus 10 I2 minus I1 minus 2 I2 is equal to 0. So this will be actually 10 times I1 minus 12 I2 is equal to 0. This we call it equation number 2. So from 1 and 2 we put it in a matrix form. So this is I1 and I2 and this is the right hand side. So here it will be minus 15, 10, minus 40, 10, minus 12, 0. Alright. So if you solve this simultaneously, we have two unknowns and two equations. So we get the value of I1 as 6 amperes and the value of I2 as 5 amperes. So as you know that we have the direction of I2 dash is same as I2. So I2 dash is basically equal to I2, which is equal to 5 amperes for the first case. Alright. So we have calculated the value of I2 dash for 40 volt voltage source. Alright. In this way, next we have to consider 20 volt voltage source, considering other two voltage sources as short circuit. Then the third case, 10 volt voltage source. Alright. So let's consider 20 volt voltage source. We redraw the circuit with 20 volt voltage source alone. Remaining sources will be short circuited. So let me draw the circuit again. So we will write over here for the second part, consider 20 volt voltage source alone. Alright. So if you refer the circuit, I will short circuit the 40 volt voltage source. Then I'll only consider 20 volt voltage source, which is 20 volt. Then here we have a resistor of 10 ohms. Here we have 2 ohms, and there is another voltage source which will short circuit over here. Alright. Again, we cannot reduce this 2 ohm resistance further because we need to find the current. This is called as I2 double dash. Alright, let me expand it a little. This will be 5 ohms. This is 5 ohm resistance. Alright. And here again we can apply simple mesh analysis and find the value of I2 dash. Let's mark this current as, let me use another color. Let us mark this current as I3 and this current as I4. So we know basically your I4 is equal to I2 double dash. So let's apply KVL to loop number 1. So what do we get over here? We get minus 5 I3. Here it is plus minus. So it will be minus 20 minus 10 times I3 minus I4 is equal to 0. So let's rearrange this. You will get minus 15 I3 plus 10 I4 is equal to 20. And let's call it equation number 3. Alright. Now we apply KVL to loop number 2. So what do we get? Minus 10 I4 minus I3 minus 2 I4 is equal to 0. Alright. So over here we get that is 10 I3 minus 12 I4 is equal to 0. Now we have two equations. We'll take two unknowns are there, I3 and I4. So put it in a matrix form. So you'll get minus 15, 10. This is I3, this is I4. Here you have 20, 10, minus 12, 0. So solve this simultaneously. You will get the value of I3 as value of I3 is coming out to be minus 3 amperes and value of I4 is coming out to be minus 2.5 amperes. Alright. Now remember in the first case when we calculated the value of I2, the direction of current was from left to right. Alright, so remember it. Here actually I4 is I2 double dash, so I2 double dash is equal to I4 is equal to minus 2.5 amperes. Here the direction will be from left to right. Alright. Now if you want to write it as positive, you will show the direction as opposite. Okay, it's one and the same thing. So we got the value of I2 double dash. Are you understanding that these steps are mechanical? Only thing is we need to patiently apply it for all the cases. So now we have considered 20-volt voltage source alone. Now we will consider 10-volt voltage source alone. So we'll make 20 volt and this 40 volt as short circuit. So let's do that and write the current values. So let's go to the third case. Consider 10-volt voltage source. Okay, we consider 10-volt. Let me draw it over here. 10-volt voltage source alone. Okay, we consider 10-volt voltage source alone. So let's draw the circuit. So here 40-volt voltage source will be short circuited. We have 5 ohm resistance. Here this voltage source will be short circuited. Then we have 10 ohms, 2 ohms, and here is my 20 ohm volt voltage source. 10-volt voltage source, sorry. All right. And here we need to find the value of I2. So this I2 is called as I2 triple dash. All right. Now, if you see carefully, no need to apply a KVL over here. 5 ohm and 10 ohm can be in parallel with each other. Okay. There is no way there's 2 ohms resistance involved. So what we will do is we can write 5 ohm parallel to 10 ohm, which will give you 3.33 ohm. So if I draw the circuit again, I have 3.33 ohm. Then we have in series 2 ohm, and then we have a voltage source 10 volt, and we need to find the current over here I2 triple dash. So normally we can apply your Ohm's law and find the value of I2 triple dash. It will be 10 volt because we are going from minus to plus, so it will be 10 divided by 3.33 plus 2. So that is coming out to be 1.875 amperes, and the direction is from left to right. So this is the value of I2. Let me highlight it over here. This is the value of I2 triple dash. All right. And what does the superposition theorem says? So we can write step number 4 as by superposition theorem. By superposition theorem, what can we say? We say that the current flowing through 2 ohm resistance will be I2 dash plus I2 double dash plus I2 triple dash. Okay, so what's the value of I2 dash? I2 dash is 5 amperes and the direction is going from left to right. So we write here I2 equal to 5. Then I2 double dash is 2.5, but the direction is reversed. So it will be minus 2.5, and I3 is 1 point. It will be plus because direction is from left to right. 1.875 amperes. So this comes out to be current flowing through 2 ohm resistance will be 4.375 amperes. Alright. So this is the value which we get with superposition theorem. So what we can do is we can cross check this in LTspice. So I've kept the LTspice window open. Let us draw the, let us, make the main circuit and then do the analysis. So let me remake it in the LTspice schematic. So first I have a voltage source over here. Another voltage source will be over here. And another one in reverse direction will be over here. Let's say over here. Alright. Now we need to connect the resistors. So we have one resistor over here. Another we have it over here. And another over here. Alright. So we are making the circuit with all the components and we are checking the current flowing through 2 ohm resistance. Let us check whether it's coming out to be same as what we got from superposition theorem. We need to add one ground also. So here it is. Without it, it won't give the result. So we have connected it to the ground. Now next, this will be around 40 volt. This resistance will be 5 ohm resistance. This voltage source will be 20 volt. This will be 2 ohm. This is 10 ohm, and this will be 10 volt. All right. So this is my circuit which I have made. And remember, current flowing out of the voltage source in LTspice is considered to be negative. So simulate, run, DC operating point. Uh, 2 ohm resistance is R2, so I of R2 we need to find out. Don't consider the sign. Sign will be, I already told you, it will come negative, but it's not just because of LTspice. So I of R2 is 4.375. As you can see, we got it perfectly. Answer is matching with superposition theorem. All right. Okay. So don't consider a negative sign. It's because of LTspice error. Okay. So now let's solve another numerical. Let me go to the next numerical. So next numerical is down. So we can say over here numerical below. Okay. We'll go to the next. So this is the second numerical on your superposition theorem. We need to find current through 10 ohm resistance. So here it is I10. Okay. And how many sources we have? We have two sources, 1 and 2. So let's say due to 10 volt voltage source, the current is I10 dash, and due to 4 ampere current source, we'll find I10 double dash. And then according to the superposition theorem, I10 will be I10 dash plus I of 10 double dash. All right. So this is our strategy. So let's start. All right. So let's write the solution. So first we consider 10 volt voltage source alone. So let me draw the circuit over here. We have 1 ohm, then we have 10 volt voltage source, then we have 10 ohm over here. This current source will be open circuit, and we have a 5 ohm resistance connected over here. 5 ohm, 2 ohm. Now let us concentrate in this part. This current flowing to 10 ohm, we can call it as I10 dash. Alright, now we can apply a simple mesh analysis to calculate the value of I10 dash. So these are the two loops. We can consider current flowing through first loop is I1 and current flowing through second loop is I2. And what can we say observation about I2? I2 is equal to minus of, or we can write it as I10 dash is minus of I2 because the directions are opposite. Alright, now we'll apply the KVL and find I1 and I2 very quickly. So KVL applied to loop number 1, this loop over here. So we have minus plus, so it will be plus 10 minus I1 minus 10 I1 minus I2 is equal to 0. All right, and what do we get over here? Minus 11 I1 plus 10 I2 is equal to minus 10. Let's call this equation number 1. Now we apply KVL to loop number 2 in this loop over here. So we have minus 10 I2 minus I1 minus 2 I2 minus 5 I2 is equal to 0. So if we simplify this, we get over here 10 I1 minus 17 I2 is equal to 0. Let's call it as equation number 2. So solve 1 and 2 simultaneously. Let me write before that in the matrix form. It will be easier for you all to evaluate. So it will be minus 11, 10, minus 10, 10, minus 17. Here it will be I1 and I2, and here it will be 0. Okay. So if you solve this simultaneously in your calculators, you will get value of I1 as 170 by 87 amperes, and you will get the value of I2 as 100 upon 87. All right, this is the value you will get. we made a mistake over here. I10 dash is not minus of I2. It's basically I10 dash is shared between I1 and I2. Okay. So what do we call it over here? I1 dash is basically I1 minus I2. So this is what we have. Pardon the mistake earlier we have done. So we have to write it correctly now. So finally, I10 dash will be I1 minus I2. That will be 170 upon 87 minus 100 upon 87. That will be 70 upon 87 amperes, and that will come out to be 0.8046 amperes. So this is my value of I10 due to 10 volt voltage source alone. Okay. For the next case, we'll consider 4 ampere current source alone and we'll do the analysis. Alright, so let's do it. So we write over here for the second part. Yeah. For the second part, consider 4 ampere current source alone. That means we have to short circuit your 10 volt voltage source. So here we'll have 1 ohm resistance. This will be short circuited. Then we'll have 10 ohm, 2 ohm. Here we'll have a 4 ampere current source. And finally here we have it as 5 ohms. So this is 5, this is 2. Alright, and we need to find the current through 10 ohm, that we call it as I10 double dash. Alright. So this numerical we can solve it with different techniques. We can apply mesh and nodal also. So we have not solved nodal analysis for a long time. So let's use nodal analysis. For nodal analysis, this will be the reference node, the ground node. This node we call it as 1. This node we call it as 2. We call the voltage at one node as V1 and this will be V2. I hope you have not forgotten how to calculate using nodal analysis. We have to apply KCL at node 1 and 2. So if you apply KCL, I'll consider this current outgoing. I'll consider this current outgoing. I'll consider this current outgoing. These are all, this is incoming. This is also outgoing. So we'll use nodal analysis to solve this, to find the value of I10 dash. Alright, let's do that. So we'll apply KCL at node 1. So all our outgoing current, what will be this current over here? This current will be V1 upon 1 plus this current over here will be V1 upon 10. This current will be V1 minus V2 upon 2. V1 minus V2 upon 2, that will be equal to 0. So we'll write V1. Don't put LCM, so we'll directly fractionally solve. So this will be 0.1 V1 plus this will be 0.5 V1 minus 0.5 V2 is equal to 0. We'll simplify it further. What do we get? 1.6 V1 minus 0.5 V2 is equal to 0. Let's call this equation number 1. Okay, I hope you have understood how we have applied this KCL at node 1. Now we apply KCL at node 2. So what are my incoming current? Incoming current is 4 ampere. So we can write, and another incoming current is this one. So V1 minus V2 upon 2 plus 4, and this is outgoing, which is V2 upon 5. So we can simplify this further as follows. Here we don't again put fractions, we'll just divide this. It will be 0.5 V1 minus 0.5 V2 plus 4 minus, if we take on this side, so here this will be 0.2 V2 is equal to 0. Now we club the terms, so you'll get 0.5 V1 minus 0.7 V2 is equal to minus 4. Let's call this equation number 2. This is actually 0.5. So we have two unknowns, two equations, V1 and V2 we need to find. Let's put it in a matrix form. So we have to find V1 and V2. So V1 coefficient is 1.6 minus 0.50. Here it will be 0.5 minus 0.7 and minus 4. Alright. So solve this simultaneously. and get the value of V1 and V2. So V1 is coming out to be 200 divided by 87 volt, and V2 is coming out to be 640 upon 87 volt. All right. And what we need to find? I10 double dash. So I10 double dash will be V1 upon 10. So I10 double dash will be V1 upon 10. That will be 200 upon 87 into 10. So that will be 20 upon 87 amperes. All right. So this is my value of I10 double dash. Now, by superposition theorem, we can say that this we can rub it off later. Okay. So now we apply superposition theorem. So we can write step number 3 as by superposition theorem. We can say that I10 is I10 dash plus I10 double dash. Now I10 is actually 0.8046. 0.8046. And how much is I10 double dash? It's 20 upon 87. So if we work it out, I10 will be equal to 1.0348 amperes. So, okay, so that's my current I10 by superposition theorem. So this will be by superposition theorem. All right. So let us check this out quickly in LTspice. Let me open the LTspice window. Let me open a new schematic, and let's build the circuit quickly and check whether the answers are coming all right. Okay, so let me build. So let me take a voltage source. Then I have a resistor over here, another over here, and another over here. One more we have it over here. Then we have a current source. So I'll go to component and type over there current. I'll reverse the direction by pressing Ctrl R. And then now I join them together quickly. All right. Let me connect with them via, and let me write the proper values over here. Okay, the connections are done. Okay, this wire I have to delete because it needs to be connected properly over here. All right. Now I need to connect the ground, and the ground I'll connect it with the wire. Now I'll write the values of the resistor and the voltage. So this is 1 ohm. This will be 10 volt. This is 10. This will be 2 ohm. I'm just cross checking my answer which I got. This will be 5 ohm. And what I want, current flowing through 10 ohm resistance by superposition theorem. It's coming out to be 1.03. So let's check it out. So current flowing through 10 ohm resistance, that will be I of R2, and I of R2, as we can cross check over here, it's 1.03448. So we got it as 1.0348. So that's absolutely fine. It's matching up till 3 digits. All right. In this fashion, we can check any numerical, any linear numerical consisting of resistors, voltage source and current source in any combination using LTspice. Now let me give you one numerical for your home assignment. So this is numerical number 3. So you need to find current flowing through. I'll give you a hint. Current flowing through 6 ohm resistance. So this is my 6 ohm resistance. So first you find the current due to 4 ampere current source and call that current as I6 dash. Then you consider 10 volt voltage source and call this current as I6 double dash. Then you consider 3 ampere current source. You call that current as I3 I6 triple dash. And by superposition theorem, it's algebraic sum of all the currents. And this answer is coming out to be 2.037. So please try this on your own and let me know if you get any different answer. All right. So now we completed all the theorems. We have discussed Thevenin's theorem, Norton's theorem. Last time we have discussed maximum power, and today we have discussed superposition theorem. Okay, so this completes your module number 1. Next time we'll start with AC circuits, that is module number 2. So until then, have a good day and thank you.